need AC voltage. We're done with the batteries. That's the simple stuff. All right. AC actually works on your phones, your LCD TVs, all of that. So we're going to take, in this case, 3 of them. We did 2 last time. And make sure you line up your symbols correctly, your circuit won't work. All right, so let's grab it. So we're going to take this down. I need to put my negative symbol, there's a positive negative on there, on this side, right? So I can see if I line them up correctly. Right? I'm talking about this little minus sign that's on the side there. We need 3 of these, so let's grab 2 more. And you're going to snap them all together and make sure they line up correctly. All right, looks like we're going here. Let's slide a little bit. Fail safes. Let's tell you about fail safes. Fuse, switch. Switch, leave it open. Don't turn it on. If you're an electrician or engineer, you don't work on powered house. You will kill yourself. Okay? And this switch open. Fuse, just in case something goes wrong with the power. You're going to put that at the bottom here. We need our current meter so we can understand how much energy is going through the system. All right, RLC, right? Resistor, inductor, capacitor. So, go up. Resistor. Okay, inductor. This is L, but if you do some research in engineering, you'll see what I call L. But it's actually called inductor. It's a measurement. Capacitor. This is like our extra storage unit for power. In light bulbs, you can see if it's working or not, right? This could be an AC unit, microwave, stereo system, iPod, whatever. So let's go here to bulb. We need branches of current so we can see digitally in numeric form how much current's going up and down, ammeters, right? And connect them to the actual components the way I do, or you'll run out of wires. Where my wires are going.
Are we ever going to use a reliable?
Not in here, no. You don't need it here. That's a good question. We already use, to answer Aaron's question better, we actually use the advanced section because we want to add resistance to the circuit so our fuse don't pop, right? Everybody saw what happened last time. We're going to increase it more because we have 3 voltage sources. So that's 9 times 9 times 9. Who knows what that is? So 10 points. It's 9 times 9 times 9. Hold that thought. You're going to see him. I mean, that's why I did that. Because you can actually open the tab, put equal sign. Anyway, all right. So, I'm done. You do Google for the wrong thing. Like what happened on Club Shay Shay?
729.
Huh? 729. You said 9 times 9 times 9 is what? 729. I think you're right. All right. Give yourself some points. Look. We're going to put our wires in place, and then we're going to put our measurement charts in place with a digital meter for voltage, okay? So let's do that real quick. We're going to leave enough time to tackle your quiz. And as it says, the quiz is due by 8 p.m. Trust and believe if you turn it in on Tuesday, I won't take away the points. You just got to make sure you get everything in there to get complete. I do ask you don't cheat in class. Y'all probably going to talk to each other over the weekend, I don't know. But while we're testing, I need to see if you can actually get the test done on your own without trying to talk to each other, okay? What's wrong?
Copy that. Thanks for that feedback. Record. Call when you're calling. Yeah.
Copy that. Move a little fast because I had to work clean for y'all in one section. As fast as I can, try to get out your way. And say, you're not ready for class, move for it. All right. Got all our wires in place. Basically how you should. Now our measurement devices, right? We have a lot of them out there, a lot of charts. We talk about electromagnetic spectrum, a sinusoid, or a waveform, wavelength, It's a form of energy in terms of light, sound, or in case even me talking to you is a form of energy traveling across the room. It's like lights travel across the room so you can see. All right, so we're going to take our voltage chart. We want to see how much voltage we're getting across pretty much both systems, right? So we're going to put one across the bulb at the beginning of the voltage connection, and the black goes here. You're probably going to move the chart around so you see the waveform. So we'll move it over a little bit. You see that? You see current with that, and this gives you voltage. How much power? Alternatively, let's see if, I think it was Ms. Perez that said the answer. She was right about this, right? It says stays out of range. Okay, got it? It says they are range, that means you don't have your probes on correctly. All right, now this is the waveform. Make sure you see your waveform. We're going to talk about wavelengths and sinusoids and energy. You see all of it. So zoom out so you see the whole waveform. Right? That's a good sign. They also use this in terms of if you're dying or your deathbed, right? They check your heart. That's flat line again. Anyway, numerically, what does that mean? Put that there too. Because, you know, some people like numbers, some people like symbols. Current. Well, you know these plates, they charge and discharge. You see it numerically there, but it's best if you watch the inductor system, right? So you can see the waveform of the number and understand what's happening. Let's grab another current chart, and we're going to put it right here on the capacitor, so you can also see what's happening graphically with that. All right. We need numbers on our voltage. And you're like, dang, this is a lot. It's a quiz day. I heard it. So I think this is enough, right? All right, we got to move on. It's 10:28. Did you have questions? Did you get this?
No, I was saying we got some progress.
Oh, you got some progress. Okay. It means you have an effect on the young man. We're going to flip the switch like Einstein, Frankenstein, and make it come to life, right? So let's flip the switch. And boom, it broke. You missed one thing, right? Now, what did I do last time? Now, remember? Can I get our points? What did I do last time to make sure this works?
Turn the wire.
Turn what?
The wire resistance right and the source.
Yeah, where did you go for that?
Advance.
Advance. She gets 15. Turn this on. Darcy, you keep notes. She said turn it. All right, and this is a big circuit. So you turn it on. This puts resistance or resistors inside the wire, flowing the current out. We turn on the source resistance as well. The source is 1, 2, 3. That means the current will come out slower to that too. Let's go ahead and fix it, right? We're going to pop the circuit back in place. And probably pop it a few times. Great job, Darcy. All right, so you got two screenshots. Everybody knows what they are, right? By the way, these you need to adjust because these are not really visible, right? So get zoom in a little bit, see it better. And what this changes is the time scale so you can see the graphs better, right? When you see those, let's see what those look like. And later on, if you become a good engineer, you can see these graphs and actually measure them out numerically. Two screenshots. This one is the first, called Digital Plus Mode. But the bulb's not really lighting up, is it? So how can we fix that? You right now? Check it out, folks. What did I do last time?
The red arrow.
Uh-huh.
The red arrow.
The red arrow.
Conventional. Click the
No,
bulb
I'm saying how to click the
and
bulb.
turn it up.
The bulb?
Oh no.
The AC.
Oh, who said that?
The AC.
I heard you. Yeah. She's right. She did it too. Because the AC is a voltage source, right? Good job, Luis. I think it's 15. Go ahead. Let's increase it, right? You got the frequency, you can play with that. You got the phase shift in degrees, right? Like Manhattan. So, let's try to increase that. See a little bit of light. We're going to do something else. Okay, so this one's at, if you don't know, I did this one at 60, I think. You know that? Yeah, 60. This one's going to be at 60. You got to take 60. That bulb. We gotta fix that graph. That graph, this graph, this graph, that mess. How about this one? We just want the bulb to be brighter. Notice the electrons are moving faster. So all these are 60 now, by the way. Look at that bulb again. All right, that's good enough. These graphs, they look horrible. Let's fix them.
Wait, do we even get his voltage? You're gonna need a voltage.
It looks better. Oh, that one's wrong, right?
Okay, now.
All right, now take a screenshot. All right, so you need this, and then you have the second screenshot. I think who said it was Angel.
All right, put that right here.
The second screenshot, symbols, blueprint mode. That's how you pay money, right? Come to a job and you read these, and it'll pay you about $30 an hour. Conventional, you understand how electrons actually flow in terms of engineering skills.
Don't touch the board.
Huh?
Don't touch the board.
I'm not. I might change it back, and then I'm going to go in the board. Off the way. Oh, okay. Thank you. So I'll put it back like this, right? In the Disney mode, for my cartoon people. And then you need the real world technician engineer mode, right?
My stuff not like it.
I don't know, I mean something's broke. So we're gonna take a look, get Aaron or Nicole to help you do it right. All right, I gotta get the board ready for y'all video. I'll leave this up here. Oh, we'll troubleshoot. The recording is still in our shape. That was a long little recording, so it's 50.